Yes, good morning to everyone. Okay, before getting into today's topic, okay, what topic we have discussed in the previous session. Okay, we'll go through it, then we will proceed with today's topic. Okay, what are the steps we have to follow to program the timer bar counter of 8051? I have told you few steps, correct? Can you type it in the chat? So before programming the timer bar counter, what we have to do initially? Can we program the timer bar counter when it is running? What we have to do? Yes, very good, Logus Nega. Yes, very good, Dixon. We have to stop the timer bar counter. That is the very first step we have to do. Okay. Then after that, what we have to do? After that, what we have to do? Once we have stopped the timer bar counter, what we have to do? Yes, we have to configure the timer bar counter using tmod register. That's very good. Okay. But only few people are typing in the chat. Only few people are replying in the chat. See, don't be like this. See, all of you try to answer. Okay. So very good. We have to configure the timer bar counter. After we have configured, okay. What about the next step? Yes, very good. We have to load the count value for which it has to be generated an interrupt. Say for example, after 10 counts and interrupt generate we have to put the corresponding count value. Fine. Whether we can load the count value as we require, like 5 interrupt, 5 count kapra interrupt generate whether I can put count value as 5 itself. What we have to do? Yes, as it is a up counter, okay, it is going to increment a value of 1 for every 1 machine cycle. That means if now 5 value put after 5 count and interrupt generate. So for that, what we have told? We have some formula, correct? How we have to load the count value? The count value to be loaded is equal to what? Maximum count minus the desired count plus 1, correct? Okay, after we have loaded the count value, what we have to do? Once we have configured and loaded the count value, what we have to do? Yes, we have to run the timer bar counter. Very good. Okay, we have to run the timer bar counter. Fine. To run the timer bar counter, which bit in TCON we have to use? And you people type it in the chat. TCON register la timer control pandradhukku we are, yes, very good. TR1 and TR0. Okay, TR1 for timer bar counter 1 and TR0 for timer bar counter 0. Fine. Okay, very good. Fine. Finally, what we have to do? We have to enable the timer overflow interrupt. Fine. So these are the steps we have to follow to program the timer bar counter. Then we have discussed about the serial communication, different types. Fine. Then what are all the SFRs associated with the serial Uart? Serial Uart program pandradhukku enna register la irukku paathom. Can you type it in the chat? Yes, very good. Yes, con. Then yes, buff. Very good. Then PCON. Okay, in the case of PCON, we are having only one bit, that is SMOD bit available in the PCON register. So that is called as double baud rate bit. Right? So today we are going to continue the SCON register. So these are the 3 registers, special function registers we are going to use to program the serial Uart of Intel 8051. Fine. So this is the word format of SCON register. What about the purpose of SM0 and SM1? Can you people type it in the chat? So this thing and all in the previous session itself we have discussed. Continuation flow the slide again na present pannirken. What about the purpose? Yes, very good. More selection bit. SM0 and SM1 are more selection bit. This must be set or cleared by programmer only. That means by software only we have to do this. Fine. If it is mode 0, what must be the value must present in SM0 and SM1? Mode 0 bina SM1, SM0 enna value irukumpa? The order is SM0 then SM1. For modes, yes, very good. Fine. See, if it is 00, it is going to work as a shift register. If it is mode 1, it is going to work as a 8-bit Uart. already we know what is meant by 8-bit UART. The protocol last class fine. Okay. Then mode 2 and 3 both are going to be same 9-bit UART. What about the difference between mode 2 and 3? Can you type it in the chat? Mode of operation, it is going to be same for mode 2 and 3. Then which parameter is varying? Which parameter is distinguishing mode 2 and 3? On seeing the table, you can tell the answer. Yes? Yes. In the case of mode 2, it is fixed baud rate, whereas in the case of mode 3, it is variable baud rate. Okay. Can you people type it in the chat? The baud rate generation for 2 modes of operation is going to be same. What are the 2 modes? In the mode of operation, the baud rate ஒரே மாதிரி generate ஆகுது பாருங்க. Table பார்த்தே சொல்லும். Yes. Which 2 modes I have listed here is going to have same method for generating the baud rate? Very good. For mode 1 and 3, we will be going to have the same method for generating the baud rate. Okay. Kindly note down this thing. For generating the baud rate for mode 1 and 3 can be done by the generation of baud rate can be done for mode 1 and 3 can be done by timer 1. Kindly note down this. Fine. Which timer we are using for generating the baud rate? Timer 1. Don't forget this. Okay. Shall we move to the next slide? Yes. Yes. Shall we move to the next slide? Yes. Okay. Fine. What about in classroom 1? Yes. Okay. Fine. So the next bit is SM2. I have told you it is multiprocessor communication bit. Okay. Based upon the mode of operation, this bit is going to play in different way. Okay. Mode of operation of the SM2 bit role, it is going to vary. Fine. So it is set or cleared by software only. Okay. The set panna meaning enna? Multiprocessor communication mode enable agum. If it is reset, then it disables the multiprocessor communication mode. Okay. Today I will explain you what do you mean by multiprocessor communication mode in detail. Last class sollirkom, but in detail we will see today. Fine. But observe panna mattum puriyum. PPT nalla gavanicha mattum puriyum. Fine. Okay. In the case of mode 0, SM2 bit must be reset. Fine. When you are configuring the serial UART of 8051 in mode 0, multiprocessor communication mode kandipa disable panni da irukkanum. Fine. In the case of mode 1, nalla gavanikanum. In the case of mode 1, if SM2 bit is equal to 1, then receive interrupt will not be generated if invalid stop bit is received. What is the meaning for this? Mode 1 is 8-bit UART mode. 8-bit UART nu sonna kandipa start bit, 8-bit data, okay, then stop bit. Correct? The stop bit, if it is not valid, then it is not going to generate the interrupt if SM2 bit is equal to 1. Okay. Suppose SM2 bit nama 0 panirno appadina, it won't consider whether the stop bit is valid or invalid. Adu edume check pannama straight away it is going to accept the data. Fine. In the case of mode 2 and 3, SM2 bit 1 pannirunda. Fine. What about the name of mode 2 and 3? Can you people type it in the chat? What about the description of mode 2 and 3? Can you people type it in the chat? Mode 2 and 3, enna name sono? Description. Mode 0 na shift register. Correct. Mode 1 na 8-bit UART mode. Correct. Mode 2 and 3 enna sono? Kindly type it in the chat. Yes, very good. 9-bit UART. Fine. So 9-bit la namakku normal 8 bits irukum. The 9th bit, what we are going to receive, that we call it as RB8. Okay. Ungoda SCON register la pathina theriyum, you will be having 1 bit RB8. What is the meaning for this? When you configure the when you configure the serial UART of 8051 in mode 2 and 3, you will be going to receive 9 bit. 8 bits it is going to receive in the SBUF register. The 9th bit it is going to be available in the SCON register. Fine. If it is 0, if RB8 is 0, then receive interrupt generate ஆகாது. Kindly understand this. If I enable SM2 bit, that means SM2 bit set பண்ணிருந்தோம்னா interrupt generate ஆகாது. எந்த கண்டிஷன்ல 9th bit எனக்கு 0 வந்தா interrupt generate ஆகாது. Okay, then when the interrupt will be generated? RB8 0 வந்தா interrupt generate ஆகாதுன்னு சொல்றோம். Then what about the case to get interrupt generated? RB8 என்ன வந்தா interrupt generate ஆகும். What about the logic of RB8 so that interrupt will get generated? Yes, very good. Clear? When I am configuring the 8051 UART in mode 2 or 3, the 9th bit what I am going to receive must be 1. Otherwise, interrupt won't be generated. There is a meaning for that. Okay. Now we will clearly understand, clearly see what is meant by multiprocessor communication bit. Okay, multiprocessor communication. Okay, fine. So now we are going to elaborate the multiprocessor communication mode. The very first thing, what I have told about multiprocessor communication mode, how many master and how many slave will be going to have? போன கிளாஸ்ல நான் சொல்லியிருந்தேன் எத்தனை மாஸ்டர் இருக்கும் எத்தனை ஸ்லேவ் இருக்கும்னு சொன்னேன். I have told you the name repeatedly. When I say multiprocessor communication mode here in 8051 UART, there should be only one master. You can have multiple slaves, correct? Okay, so I am going to consider this is my master microcontroller. Fine. So in the particular microcontroller, master assume பண்ணிக்கிறேன். Fine. Then I will be going to have many number of slaves. Okay. What about total number of slaves you can have with a single master? Can you see the diagram and answer? How many slaves totally we are having in this diagram? The dot indicates slave 3, slave 4 up to slave 25. Yes, very good, Anthony Surya. 256 slave microcontrollers we can have. Fine. So this we call it as multiprocessor communication mode. That means any slave can communicate with the master, but the communication can be initiated by the master only. Single master, multiple slave configuration we are having. Okay. The next thing is slave to slave communication is not possible without master. நல்லா ஞாபகம் வச்சுக்கணும், ஒரு ஸ்லேவ் இன்னொரு ஸ்லேவ் கூட கம்யூனிகேட் பண்ண முடியாது without the help of master only. Sorry, with the help of master microcontroller only it can able to communicate with slave to slave. Fine. Directa ஒரு slave இன்னொரு slave கூட communicate பண்ண முடியாது. That is the second point. Fine. Okay. Now we will be going to have two lines for serial communication. Okay. ஒன்னு நான் இங்க என்ன display பண்ணிட்டேன் TXT. What about the other line? What about the other pin? TXD is for transmission. What about the other pin? Serial UARTல ரெண்டு pin இருக்குன்னு பார்த்தோம். கரெக்ட்டா? TXT இன்னொன்னு என்னதுப்பா? Kindly type it in the chat. Transmissionக்கு ஒரு பின்னா கண்டிப்பா இன்னொன்னு என்ன பின் இருக்கும்? Receptionக்கு ஒரு பின் இருக்கும். What about the name of the pin? Yes, very good, Sajis. Very good. RXD, very good. Danya, Anthony Surya, Lovely, Sivakumar. Okay, thank you. Okay. So this I am going to consider as TXT line. Red color la mark பண்ணிருக்கிறது TXT line. Then green color la நான் mark பண்ண போறது RXD line. So two lines. Apart from that, you should have a common ground. Yes. Apart from that, you must have common ground. So that I didn't mention in the slide. Okay. You have to assume the master lane எனக்கு ஒரு ground wire எல்லா slaveக்கும் போகும். Fine. Now my question is how you have to connect the slave to your master. TXT pin of master should be connected to where? To the slave. Master transmit பண்ணா slave தானே receive பண்ணணும். So the transmission pin of master must be connected to where? Where? Yes, receiver end. Very good. Fine. So it must be connected like this. நல்லா கவனிச்சீங்கன்னா தெரியும். Green color நான் என்ன சொன்னேன்? RXD pin. நல்லா கவனிங்க. Master transmit பண்ணுது red color lineல. Okay. Where the slave got connected? RXD pin ல connect ஆயிருக்கு. Fine. Cross connect பண்ணணும். TXD of master must be connected to all slaves at RXD pin. Similarly, RXD pin of master must be connected at TXD of all slaves. Yes. Is it clear now? Is it okay? Is it clear now up to this? Yes, fine. Now we are going to discuss about the multiprocessor communication. Fine. So this configuration we call it as multiprocessor communication mode. Okay. This kind of thing we call it as multiprocessor communication. Fine. Okay. You can see master is not provided with any address, but all slaves are provided with an 8-bit address. Yes or no? Yes or no? All slaves are provided with an 8-bit address. How I have addressed the slaves? 00H for slave 0, 01H for slave 1, up to FFH for slave 255. Yes? Okay, fine. Now, multiprocessor communication enable பண்ணோம்னா எந்த bit set பண்ணிருக்கணும்னு சொல்லுவோம். SCON ல எந்த bit நம்ம set பண்ணிருக்கணும்னு சொல்லுவோம். Which bit in SCON must be set to enter into the multiprocessor communication? Yes, very good. SM2, correct? So, இப்போ நல்லா கவனிங்க மாஸ்டர்ல என்ன பிட் SM2 என்ன செட் ஆயிருக்கு பாருங்க. I mean என்ன வேல்யூ இருக்குன்னா 1. Similarly, all slaves it is going to have the value 1. That means what? All the microcontroller master as well as slave are in the multiprocessor communication. Fine. Now your master microcontroller is going to send the address. நல்லா கவனிக்கணும். Now your master MCU send the address. நல்லா கவனிக்கணும். If it want to send the address, what about the value of TB8 now? Can you see in the slide? What about the value of TB8 now? What about the value of TB8 now? 1. Apna meaning enna na solren. Whenever the master want to send address, it must keep TB8 as 1. Okay. Now, if enna address vechirukku parunga, SBUF plus 01. Master is sending the address 01. SBUF plus 01 value vechittu SM2 set ஆயிருக்கு TB8 1 இருக்கு. Fine. So it is going to be transmitted to all the slaves. நல்லா கவனிக்கணும். It is going to be transmitted to all the slaves. So இப்போ எல்லா ஸ்லேவ்லயும் என்ன ரிசீவ் ஆகும்? RB8 ல என்ன ரிசீவ் ஆகும்? Can you people type it in the chat? Which logic it is going to receive at RB8? All slaves. Yes. See, TB8 வந்து இங்க 1 இருக்குப்பா. அதான் 9th bit, கரெக்ட்டா? அப்ப இங்க ரிசீவ் ஆகக்கூடிய 9th bit என்னவா இருக்கும்? கண்டிப்பா எல்லா ஸ்லேவ்ஸ்லயும் 1 only, correct? Yes. So it will be like this. So all slaves get interrupted. How I am saying? எல்லா ஸ்லேவ்லயும் RB8 இப்போ 1 தான் ரிசீவ் ஆயிருக்கு. அப்படின்னா மீனிங் என்ன? SM2 செட் ஆயிருந்தா RB8 1 இருந்தா மட்டும்தான் இன்டரப்ட் ஜெனரேட் ஆகும். Fine. Now all the microcontroller will get interrupted. So எல்லா microcontroller என்ன செக் பண்ணனும் இப்போ? What all microcontroller has to check now? The received thing is address. Correct? இப்போ எல்லாத்துக்கும் interrupt வந்துருச்சா? இப்போ இது ரிசீவ் பண்ணது என்னது? Address. Correct? Which slave address is getting mapped? எந்த slave address வந்து select ஆகும்? Which slave will get selected? எல்லா ஸ்லேவுக்கும் சேம் அட்ரஸ் தான் போகுது 01. Which slave it is going to be addressed? Yes, slave 1. So now slave 1 is got address. Correct? இத்தனை ஸ்லேவ் இருந்தாலும் எந்த அட்ரஸ் மேட்ச் ஆகுதோ அந்த ஸ்லேவ் மட்டும் என்ன ஆகுது? செலக்ட் ஆயிடும். Fine. That slave what it has to do? இந்த ஸ்லேவ் என்ன பண்ணும் அப்படின்னு பாத்தீங்கன்னா it is going to reset the RB8 bit. What is the meaning for this? நல்லா கவனிங்க. The slave 1 now exits from the multiprocessor communication mode by resetting the SM2 bit. தெரியுதுங்களா? எல்லா மைக்ரோ கண்ட்ரோலர்லயும் என்ன இருக்கு? SM2 bit 1 இருக்கு. எந்த slave address பண்ணமோ அதுல மட்டும் என்ன ஆயிடுச்சு? SM2 bit. What about the condition of SM2 bit at slave 1 now? Reset, correct? 0 இருக்கு. That means it exits from the multiprocessor communication. Fine. Now the master is going to send the address, sorry, data now. Already send பண்ணது address. Address send பண்றதா இருந்தா TB8 must be 1. What about TB8 now? What about the value of TB8 now? What about the value of TB8 now? Yes, it is 0. Fine. So இப்போ எல்லா ஸ்லேவுக்கும் என்ன போகும்? Value TB8 0, SBUF ல 37 போகும். Fine. Can you say which microcontroller, which slave microcontroller will get interrupted now? That's my question. Ella slave kume the data ponuchi. Correct? Which microcontroller only get interrupted now? What about the other slaves? Just imagine, received bit 0 irunda, SM2 bit 1 irukkrappa, received bit 0 vanda interrupt generate aguma agada. If the received bit is 0, if SM2 bit is set, then interrupt will not be generated to that particular microcontroller. Yes, so slave 1 மட்டும் என்ன பண்ணிருக்கோம், SM2 bit clear பண்ணதுனால இங்க வந்திருக்க டேட்டாவோட 9th bit 0 இருந்தாலும் interrupt ஆகும். So what it means? It is having the data 37. Other microcontrollers will not get interrupt, so it won't consider the data. Is it clear to everyone? Is it clear to everyone? Yes, fine. Okay. இப்போ ஒரு slave இருந்து இன்னொரு slaveக்கு communication நடக்கும்னா எப்படி பண்ண முடியும்? How it can be done? How it can be done? Slave to slave communication நடக்கும்னா எப்படி data transfer ஆக முடியும்? Yes, very good. Through master. So what the slave has to do? The slave has to interrupt the master. Okay. So that the master know which slave it is. It want to communicate. Correct? Fine. See, there should be some protocol or rules or some program you have to write to establish this. Fine. நம்ம சொல்றதெல்லாம் வார்த்தையில ஈஸியா சொல்லிடலாம். இதுக்கு எல்லாத்துக்குமே நம்ம என்ன பண்ணணும்? We have to write program. Fine. With the help of master only, one slave can communicate to the other slave. Without master, they can't communicate to each other. That is the thing. Fine. So this is what about multiprocessor communication. Fine. Okay. See, you people can give some feedback. Sometimes if you are not able to understand the concept, we can have such slides. Okay. Fine. Now we will continue. So after multiprocessor communication mode is over, again slave 1 will set the SM2 bit, so that again all slaves is waiting for the address. Address send பண்றதா இருந்தா TB8 என்ன இருக்கணும்? 1. Data send பண்றதா இருந்தா TB8 0. That's it. Okay. Now REN bit last class சொல்லியாச்சு. Reception you can enable or disable by setting or clearing the REN bit. Fine. If it is set by the software, then reception got enabled. If it is reset, reception will get disabled. Fine, that's it. Fine. Then TB8, RB8, now you people know. In the case of 9-bit Uart mode, TB8 and RB8 is going to have the 9th bit. Fine. At the transmitter end, we will be having TB8. At the receiving side, we will be having RB8. Fine. The bit, the 9th bit, it want to transfer. It must be written into TB8. That means it is set or cleared by the software. Okay. What about RB8? Set or cleared by the hardware based upon the bit, 9th bit received. Fine. So this is only for mode 2 and 3. Fine. Whereas RB8 is for mode 2 and 3, 9th bit received. For mode 1, it is going to be considered as a stop bit. That's it. For mode 0, it is not used. Fine. So that's all about TB8 and RB8. Fine. What about TA and RI? TA stands for what? Can you type it in the chat? TA stands for what? Transmit interrupt. What about RI? What about RI? TA means transmit interrupt. RI means receive interrupt. Fine. Whenever a byte of data is transmitted, fine. See, when you are writing a data into SBUF, it is going to start the communication. 1 by 1 bit, it is going to send serially. Fine. After it sends an 8 bit of data, it is going to generate an interrupt called transmit interrupt. Fine. Similarly, when you are having a data byte received, at that time this particular interrupt will get generated. That means in general we have serial UART. The sources are transmission interrupt and reception interrupt. Fine. If any one of this occurred, serial interrupt will get generated. Fine. As of now, we have discussed only 5 interrupts we are having, 2 external interrupts, 3 internally generated interrupts. What are the 3 internally generated interrupts? Timer 0 overflow interrupt, timer 1 overflow interrupt, then serial interrupt. Please consider serial interrupt. It is either due to transmission or reception. There are 2 sources for serial interrupt. Fine. Appo interrupt namakku occur aanichuna namakku edanaala nadandhuchinu theriyadu. In the case of other interrupt, the interrupt flag will get automatically reset when its ISR routine is going to be executed. ஒரு இன்டரப்ட் வந்து அதோட ISR routine போனா ஆட்டோமேட்டிக்கா flag clear ஆயிடும் படிச்சிருக்கும் கரெக்ட்டா. But in the case of serial interrupt, TI and RI must be cleared by software only. We have to clear it. We don't know due to which I have got the interrupt, serial interrupt, whether due to transmission or reception. So once you go into the ISR routine, you have to check whether TI bit is set or RI bit is set. If TI bit is set, this interrupt is due to transmission. If RI bit is set, this particular interrupt is due to reception. Fine. On examining the TI and RI bit, we can know due to which purpose we have got this serial interrupt. Okay. Fine. So let's specific mode 0 பொறுத்தவரைக்கும் end of the 8th bit transmit பண்றப்ப interrupt generate ஆகும். Fine. In the case of mode 1, 2 and 3, at the beginning of stop bit send பண்ற அந்த beginningல நமக்கு interrupt generated. That indicates 1 byte நான் transfer பண்ணிட்டேன். Fine. Next byte நீ கொடுக்கிறதுனா கொடு. That's the meaning for it. Similarly, receive interrupt பொறுத்தவரைக்கும் at halfway through the stop bit. நம்ம ரிசீவ் பண்ணக்கூடிய அந்த 8 bit டேட்டால ஸ்டாப் பிட் வருது இல்லைங்களா இந்த ஃப்ரேம்ல. So at the half of the duration will be getting the interrupt. Fine. So that's all about the SCON register and its functionality. Okay, each bit in SCON it is going to have different function. Fine. Now we will go with the mode of operation. First we will go with the mode 0 operation. Fine. Before that, we have to know how to configure the serial UART of 8051. Fine. To configure or control the serial UART of 8051, which register we have to use? SCON register. Fine. Now, for this given problem, can you people say the word format? I mean value. In mode mode 1. What about the value I have to fill at SCON.7 and SCON 6? Kindly type it in the chat. Mode 1 correct. So what about the value at MSB bit and the next bit? Yes, very good. 0 and 1. Very good. Super. Fine. With reception enabled, I have to enable the reception. So what about the logic at this position? SCON.4. Reception enable panna pora. Yes. Yes, very good. 1. Multiprocessor communication mode we have to disable. So what about the value at SM2 bit, corresponding bit? Yes, again it is going to be 0. SM2 bit is equal to 0. Fine. Okay. So now all other bits we have to clear it. We have to assume நம்ம எந்த 9th bit இப்ப transmit பண்ண போறது இல்ல. We are not going to have any reception 9th bit. Then TI, RI, everything must be clear. That's all. What about the word we are having? 50 Hz. So the meaning is the serial UART of 8051 configured in mode 1 with reception enabled, okay, and multiprocessor communication mode got disabled. Fine. So this is the meaning for filling this value with SCON register. That's it. Okay. What about the instruction you have to use to move this value 50 Hz to SCON register? What must be the instruction we have to use? Can you people type it in the chat? Instruction set marandu pocha enna paakalam. 50 Hz SCON register la podnumna enna instruction use pananum? Kindly type it in the chat. The value and the register la podnumna enna instruction use pananum? Just type it in the chat. Marandu pocha instruction. Yes. Have you forgot the instructions? Program எழுதிட்டே இருந்ததா? Yes, very good. Shivakumar, I think you did one small mistake. Yes, move scan, comma, hash 50 போடணும். Okay, Shivakumar. Yes, very good. Okay, very good. Very good. Classroom 2 யாருமே answer பண்ணல. Fine. See, this must be the instruction we have to use. Write the value 50 into the scan register. Okay, classroom 2 பார்த்துக்கோங்க. This is the instruction we have to use. Okay, fine. Now, SBUF register. What is the purpose of SBUF register? It is going to be used to transmit the data as well as used to receive the data. Fine. As we told, 8051 is full duplex UART. SBUF register is a serial buffer register used to hold a byte of serial data to be transmitted and received. நம்ம transmit பண்ணக்கூடிய 8-bit டேட்டாவும் SBUF ல தான் போடுவோம். ரிசீவ் ஆகக்கூடிய 8-bit டேட்டாவும் SBUF தான் வரும். That means physically we have two buffer register. One is SBUF read only for reception, then SBUF write only for transmission. Fine. Okay, sir. இதுல SBUF read only எப்ப access ஆகும், SBUF write only எப்ப access ஆகும் அப்படின்னு பாத்தீங்கன்னா, the instruction that uses SBUF as source. நல்லா கவனிச்சீங்க தெரியும். Move A, SBUF. SBUF is the source now. Correct? So இப்போ எந்த SBUF register address ஆகும், read only SBUF will get address. Similarly, SBUF destination அங்க யூஸ் பண்ணிருக்கோம். அப்ப மீனிங் என்ன? Write only SBUF. To transmit a data, you have to use this instruction. Move SBUF, A or SBUF, immediate data or SBUF, RAM address content, whatever it may be. Fine. Similarly, for reception, உங்களுக்கு interrupt வந்த உடனே SBUF read பண்ணினீங்கன்னா, you can able to have a value. That is the received byte of data. I hope it is clear now. SBUF அப்படின்றது the same name we are going to use for transmission as well as reception, but physically there are two registers available. Okay, that you have to understand. That's why we are saying it is full duplex. இது transmit பண்ணக்கூடிய அதே டைம்ல ரிசீவும் பண்ண முடியும். That's why we are saying it is full duplex. Okay, fine. Then pecan register ரொம்ப டீடைலா பார்க்க வேணாம். இதுல ஒரே ஒரு பிட் மட்டும் தான் நமக்கு யூஸ் ஆக போகுது. எந்த பிட்? Can you type it in the chat? Out of this bit, which bit we are going to use for programming the serial UART? Yes, can you type it in the chat? SMOD, very good. SMOD stands for double bauded bit. Double bauded bit. What meaning is when this particular bit is set, it is applicable only for mode 1, 2, and 3, not applicable for mode 0. Fine. 1 பண்ணீங்கன்னா double the baud rate of serial UART நடக்கும். 0 பண்ணீங்கன்னா it does not double the baud rate. Our normal baud rate நமக்கு maintain ஆகும். Fine. Regarding this bit, I will tell you now, but don't get confused. So in the bit GF1, GF0, that is for general purpose user flag. Already flag, I mean PSW register we have one user flag F0 bin correct. So inge rendu user defined flag irukku. Fine. General purpose user flag. Fine. Then PD stands for power down mode enable bit. Then IDL stands for idle mode enable bit. Fine. We are having two power saving modes in Intel 8051. One is idle mode, the other one is power saving, I mean power down mode. Fine. So idhula endha mode நம்ம enable பண்ணுமோ அதுக்கு corresponding bit நம்ம set பண்ணிக்கணும். There's a meaning for it. Okay. So the pecan stands for power control register only, but MSB bit of pecan we are using for doubling the baud rate. நீங்க baud rate எல்லாம் configure பண்ணிட்டீங்க. இப்ப baud rate double பண்ணனும்னா simply what you have to do by setting the SMOD. That's it. Okay. So that's all about all the SFR associated with serial UART of 8051. Fine. So SFRs related to serial UART of 8051. Moon irukku, SCON, SBUF, then pecan, MSB bit only we are using. Fine. Okay. Now mode 0, shift register mode. The path ungalku enna theriyum? What you peoples are understanding? In the case of shift register mode, the TXD pin, it is going to work as a clock. Okay. the TXD pin, it is going to work as a serial clock. Whereas the RXD pin, it is going to be used for both reception as well as transmission. In the case of mode 1, it can also be called as synchronous serial communication. Okay, synchronous serial communication mode. Synchronous na enna sonna nyabagam iruka? The word synchronous means what? The clock source to the transmitting and receiving device, it is going to be common. That means, inge internal generate agra adhe clock pulse TXT pin valiya receiver ku podu. That means same clock pulse for the transmitter as well as the receiver. Fine. Here we have only one pin. That means what? At some point of time, you are going to transmit the data. Inge SPOF data putting the transmit agapodu. That's it. What about in the case of receiving end? It is going to receive the data. That means the data communication is half duplex, as we are having only single line for transmission as well as reception. Rendu diagram parunga. First diagram la RXD pin valiya transmission nadakudhu. It is from the microcontroller to the receiving device. In the case of second diagram, you can see data is from the transmitter to the microcontroller. Fine, but one can be done at a time, as we are having only single pin for transmission as well as reception. In the case of mode 1, for each mission cycle, okay, for each TXT clock generated, you will be going to transmit 1 bit of data. Fine, to transmit an 8 bit of data, it needs to generate 8 clock pulses. So automatically TXT pin la clock generate aga arambichirum when you configure in mode 0. Fine, sorry, serial port as in mode 0. Mode 1 kadiyadu. In mode 0, the serial port operates as shift register. Sorry for this. There is a mistake in the slide. Correct it. The serial port operates as shift register. That's it. Okay. So TXD generates the serial clock. RXD is used for both transmission and reception of data. Fine. Simply, this particular mode of operation, we call it a shift register mode. Fine. So, this is half duplex synchronous serial communication. Correct? The serial port is synchronous and half duplex. Fine. Okay. So, here baud rate generate so, here baud rate generate the oscillator frequency get divided by 12. That is the clock we are having to the serial Uart. The same clock it is going to TXD pin. That means what? That means what? For every one mission cycle, 1 bit of data it is going to be transmitted. That's the meaning for this. Yes? Is it clear? So what about the baud rate in this case? So in the particular mode la baud rate value eppadi kandupidikka porom appdin pathina baud rate is equal to FOSC divided by 12. That's all. Fine. Find the frequency of serial shift clock of serial Uart configured in mode 0, not mode 1 kadiyadu. Sorry. This is also mode 0. We are speaking about mode 0 only, right? Find the frequency of serial shift clock of the serial Uart configured in mode 0. Assume the crystal frequency is equal to 12 megahertz. Yes, serial shift clock. So the frequency enna varum appdin pathina FOSC divided by 12. That means 12 megahertz divided by 12. That is equal to 1 megahertz. So this is the baud rate. This is the clock pulse at which the TXD pin is generating the clock pulse. This is the frequency at which the TXD pin is generating the clock pulse. Fine. Okay. Now we will go with the mode 1. This is the actual Uart. Fine. 8-bit Uart. Fine. So inge eppadi connect pannirkom parunga. TXD pin of microcontroller is connected to RXD pin of the transceiver. Transceiver means it can able to both transmit as well as receive. If it is able to only transmit, then we can call it as transmitter. If the device is capable of only able to receive, then we can call it as receiver. If a device is capable of doing both, then it can be called called as transceiver. Fine. So TXD RXD kuda connect ஆயிருக்கு. Then RXD is connected to TXD. That means cross connected பண்ணிருக்கோம். Cross connection we have established. Fine. So in mode 1, the serial port operates as a 8-bit serial Uart. Fine. So TXD is used for transmission of serial data. RXD receives the serial data from the TXD pin of transceiver. Fine. Okay. So already we have told 8-bit Uart அப்படினா அதோட frame format எப்படி இருக்குன்னு பார்த்துப்போம். In mode 1, each bytes are transmitted or received in a fixed frame format. Start bit 1 bit, 8-bit data. Yes, LSB first, then stop bit 1 bit. So that is the thing in the case of mode 1. So it is like this. நல்லா கவனிச்சீங்க தெரியும். Marking state 1 position இருக்கு. Next start bit 0, then 8-bit. Either it is going to be 0 or 1. So அதனால தான் இந்த மாதிரி format நம்ம யூஸ் பண்ணிருக்கோம். Yes. So 0 or 1 ஏதோ ஒரு வேல்யூ நமக்கு இந்த serial data ஒண்ணா சென்ட் ஆக போகுது. So initially D0 bit, then D1 bit, D2. See, the dotted line indicates the duration of each clock pulse. So initially marking state la irukku 1 bit position time ku low la irukku, then it is transmitting the 8-bit data, then stop bit it is going to be 1. Fine. So this is the thing happen in the case of 8-bit Uart. So start bit is logic 0, stop bit is logic 1. Right? Don't forget. Universally start bit oda logic enna 0, stop bit oda logic 1. So transmission எப்படி நடக்கும் அப்படினு பாத்தீங்கன்னா when no data is transmitted, as we discussed earlier, TXD line high la maintain ஆகுது. Writing a byte of data in SBUF initiate the transmission. Yes, see SBUF la நீங்க ஏதோ ஒரு data நீங்க போட்ட உடனே the communication is going to start. Fine. So first you are என்ன பண்ணும், start bit send பண்ணும், then 8-bit data, then stop bit. Fine. So at the beginning of the stop bit, transmit interrupt generated. That indicates a byte of data has been transmitted. This is the case happening in the transmission side. Reception side la enna nadakum appdi pathina, if reception enable bit is set, alla gavanikanum, if REN bit is set, then only the Uart allows the incoming serial data. Fine. Okay, இப்போ REN bit set ஆயிருக்குன்னு வச்சுக்கலாம். So what about the receiver role? If no data is being received, RXD line வந்து highly தான் maintain ஆகும். Therefore, receiver waits for logic 1 to 0 transition. The arrival of start bit indicates a data byte is following for reception. Start bit is skipped. Start bit is skip பண்ணிடு. It will check only whether the data is receiving or not. Fine. Start bit consider பண்ணாது. It is going to skip the start bit and it is going to consider the next 8 bits. That is going to be data byte are shifted into the serial shift register. Fine. Nalla gavanikkanum. The following occurs after a byte is shifted into the shift register. So in the ஒரு byte data எனக்கு receive ஆயிடுச்சு அப்படின்னா stop bit is copied to RB8 in SCON register. நான் சொன்னேன் இல்லைங்களா, mode 1 பொறுத்த வரைக்கும் RB8 ல receive ஆகக்கூடியது stop bit. Fine. The data in the shift register is moved to SBUF read only register. Automatically move ஆயிடும். Fine. அதுக்கப்புறம் interrupt generate ஆயிடும். RA flag gets set. That's the meaning for this. The interrupt எப்ப generate ஆகும்னு படிச்சோம், half the way through the stop bit. When stop bit is received, fine, RA flag gets set that indicates a byte of data is received. Fine. Stop bit receive ஆக ஆரம்பிக்கிறப்பவே நமக்கு receive interrupt generate ஆயிடும். That indicates a new data is received to the microcontroller. Fine. Is it clear to everyone? நம்ம 8-bit Uart already நம்ம explain பண்ணியாச்சு. அதனால little faster I am moving. Fine. Transmit பண்றப்ப first என்ன பண்ணும்? When you write a data in SBUF register, at that point of time, start bit 0, then 8 bits it is going to shift at, then the stop bit is going to come. Fine. At the beginning of stop bit itself, it will generate the interrupt, TA interrupt. Fine. In the case of reception enable பண்ணிருந்தா நமக்கு stop bit, start bit காக wait பண்ணிட்டே இருக்கும். Once start bit is detected, it skip the start bit and consider the next 8 bits. Fine. So the shift register வந்த உடனே SBUF registerல parallel dataவா transfer ஆயிடும். Fine. So the transfer ஆகிறப்ப என்ன நடக்குது? stop bit copy to RBA, then data in shift register is moved to SBUF read only, then interrupt will get generated. That's all about the mode 1 operation. Fine. Inge baud rate எப்படி generate ஆகுது அப்படி பாத்தீங்கன்னா variable baud rate. I have told you variable baud rate. What is the meaning for that? What is the meaning for that? நல்லா கவனிங்க. Here in the case of baud rate for mode 1, this particular timer bar counter must be configured as timer. நல்லா கவனிச்சீங்கன்னா தெரியும். என்ன மோட்ல ஒர்க் ஆகுது பாருங்க. Can you see it in the diagram? C/T bar of timer 1 என்ன இருக்கு 0, that indicates it must be configured as timer. இந்த கான்ஃபிகரேஷன்லாம் பண்ணாதான் 8051 க்கு mode 1 ல baud rate generate பண்ண முடியும். Fine. When you say mode 1 or mode 3, you must also program timer. நல்லா புரிஞ்சுக்கணும். mode 1 3 ல நீங்க serial UART கான்ஃபிகர் பண்ண போறீங்கன்னா the variable baud rate is based upon the timer 1 overflow. Timer 1 எவ்வளவு நேரத்துக்கு ஒரு தடவை overflow ஆகுதோ அதை பொறுத்து தான் எனக்கு என்ன ஆகும் baud rate generate ஆகும். Fine. Clearly understand this thing. When you are programming the serial UART in mode 1, you must also program the timer 1 so that it is going to generate the baud rate for this serial UART. Don't forget that. Serial UART மட்டும் program பண்ணிட்டு விட்டா baud rate generate ஆகாது. We have to also program the timer bar counter of 8051. என்ன பண்ணிருக்காங்க பாருங்க, timer 1 timer configure பண்ணிருக்காங்க. That means what? FOSC divided by 12. That is the frequency we are getting here. Okay. Then based upon the count value you are putting, நீங்க count value என்ன போட்டுக்கீங்களோ அதை பொறுத்து டைமரோட வேல்யூ இன்கிரிமெண்ட் ஆயிட்டே வரும். count value. Fine. At one point of time, timer overflow ஆகுறப்ப you will be having a pulse here. Please understand my wording. Please listen my wording. Whenever timer 1 got overflow, one clock pulse will come at the output of timer 1. நல்லா கவனிக்கணும். Okay? Fine. If SMOD bit is equal to 1, அப்ப இங்க வர clock என்ன ஆகும், இது வழியா போகும். Fine. SMOD bit 1 போட்டோம்னா மீனிங் என்ன, இந்த switch மேல கனெக்ட் ஆயிடும். SMOD bit 0 போட்டா மீனிங் என்ன, இந்த switch கீழே கனெக்ட் ஆயிடும். That means what? The timer generate பண்ற signal, again it is going to be divided by 16 or 32 based upon the SMOD bit. That's why we are saying it is double baud rate bit. Fine. இப்ப சென்ட் பண்றது divided by 16 அப்படின்னா ஃபாஸ்டரா நடக்கும் baud rate. divided by 32 னா baud rate half ஆயிடும், பாதி ஆயிடும். Fine. So SM to 0 இருக்கிறப்போ ஒரு baud rate generate ஆகும், SM to 1 இருக்கிறப்போ double baud rate generate ஆகும். Fine. See, problems பார்த்தோம்னா clear-ஆ புரியும். Fine. As of now, what we have to understand? In mode 1, the baud rate is determined by timer 1 overflow rate and SMOD. ரெண்டு parameter depend பண்ணியிருக்கு baud rate. In the case of mode 1 and 3. Fine. எது depend பண்ணியிருக்கு? Timer 1 overflow rate and SMOD. Fine. So timer 1 must be configured as timer in any mode. Fine. But mode 2 we are preferring as it is auto reload. Fine. Mode 2 தான் நம்ம prefer பண்றோம் because it is having the capability of auto reload. Fine. Next. See, இது புரிஞ்சுதா? இந்த diagram புரிஞ்சுதாப்பா? Whenever timer 1 got overflow, it will generate 1 clock pulse. Timer 1 16 தடவை overflow ஆனிச்சுன்னா இங்க எனக்கு ஒரு clock pulse generate ஆகும். Fine. Is it clear to everyone? What about the clock input to this serial UART? FOSC divided by 12. That is the very first thing. Again, this is going to be divided by 16 or 32 based upon the SMOD bit. Clear? Is it clear? Okay. I will show in the equation. The baud rate of the serial UART can be calculated as follow. The baud rate of the serial UART with timer 1 configured can be calculated as like this. Fine. நல்லா கவனிச்சீங்கன்னா தெரியும். FOSC divided by 12. What is the meaning for this? Diagram வச்சு relate பண்ணிக்கலாம். FOSC first divided by 12. Next, it is divided based upon the count value you are putting in the timer 1. Correct? So the base பண்ணி என்ன சொல்றோம்? FOSC divided by 12, okay, divided by timer 1 overflow rate. Timer 1 overflow rate எது depend பண்ணிருக்கு? The count value you are loading. The count value you are loading. Please understand. Fine. So 2 power S mod by 32. S mod bit 0 quota meaning என்ன? 1 by 32 divided by 32. S mod bit 1 quota meaning என்ன? 2 by 32. That is 1 by 16 divided by 16. இப்போ புரிஞ்சுதுங்களா அந்த diagram? FOSC divided by 12 divided by 256 minus the count value what I am loading. Okay. See, these are the things you have to understand. Timer 1 overflow rate depend பண்ணி தான் baud rate இங்க இருக்க போகுது. So this is the formula for that. The formula கான reason நான் சொல்றேன். FOSC divided by 12. Okay. That value divided by timer 1 overflow rate. That value divided by 2 power S mod by 32. What is the meaning for this? If S mod is equal to 0, 1 by 32 divided by 32. Correct? If it is 1, it is divided by 16. That's the meaning for this form. Okay. Now, we can have an example. The count value could be loaded in TH1. In the formula, we will derive baud rate is the formula. Correct? So, what must be the TH value of TH1 for the specified baud rate? So, formula could be altered. Yes? The formula will rearrange. Correct? This formula I have rearranged. எப்படி rearrange பண்ணிருக்கோம்? Baud rate into 12 by FOC into 32 by 2 power S mod. Okay. See, in the 256 minus TH1, in the particular value, in the side கொண்டு போயிடலாம். Baud rate கீழே கொண்டு வந்தோம். அப்ப என்ன வரும்? 2 power S mod by 32 into FOSC by 12 into baud rate. In the 256 minus TH1 இங்க போயாச்சு. Fine. அப்ப இந்த TH1 இந்த சைடும் இந்த parameter அப்படியே போனுச்சுன்னா it will be rearranged like this. 2 power S mod by 32, 256 minus 2 power S mod by 32 into FOC by 12 into 1 by baud. Fine. So this is the thing we have to use. So the meaning என்ன? இதுல SM2 என்ன value வைக்க போறோம் நம்ம தான் டிசைன் பண்ண போறோம். Baud rate we are fixing. So based on that we will be going to have the TH1 value. Fine. Example. So இதுக்கு நீங்களே கவுண்ட் பண்ணி சொல்லுங்க என்ன வேல்யூ வரும்? Find the count value to be loaded in TH1 of timer 1 configured in mode 2 for generating the baud rate of serial Uart configured in mode 1 as 9600. What is the meaning for this? What is the meaning for this? நான் generate பண்ணக்கூடிய baud rate 9600 அது கொடுத்தாச்சு. Operating frequency 11.059 அதுவும் கொடுத்தாச்சு. S mod bit 0. So what about the count value? Kindly calculate and tell. Substitute மட்டும் பண்ணலாமா? Like this we can substitute. Please listen. S mod bit is 0. Fine. Operating frequency is 11.052 megahertz. Then baud rate is 9600. Kindly find the value for this and tell me. M stands for mega. That means 10 to the power 6. Kindly calculate and tell me. கொஞ்சம் குயிக்கா கால்குலேட் பண்ணி சொல்லுங்கப்பா என்ன வேல்யூ வரும்? எஸ். See, ஜென்ரலா இந்த ஃபார்முலா எனக்கு ஞாபகம் இல்லைனாலும் இந்த மாதிரி நம்ம யூஸ் பண்ணிக்கலாம். எப்படி அப்படின்னு பாத்தீங்கன்னா the very first step what you have to do is FOSC divided by 12. 11,0598,00. Correct? Divided by 12. What about the value for this? 921600. I hope so. Correct? Yes or no? So this value has to be divided by 16 or 32 based upon S mod bit. S mod bit 0 is the meaning in divided by 32. Next என்ன பண்ண போறோம்? 921600 divided by 32. What about the value you will be getting? Yes, 921600 divided by 32. What about the value you are getting? 28800. Correct? Yes, very good. Classroom 2 ku na chat la type பண்றேன். இந்த ஃபார்முலா மனப்பாடம் பண்ணாம எப்படி பண்ணலாம்னு நான் சொல்றேன் பாருங்க. Fine. First என்ன பண்ணும் FOSC divided by 12 அது பண்ணிக்கணும். So you will be getting 921600, correct? So 921600. Again, this value divided by 32 or 16 based upon S mod bit. S mod bit on the 0 is divided by 32. So divide pannom. So what value you are getting? 28800. This is the value. Fine. Again, this value must be divided by Baud rate. Divided by 9600. So what about the value you will be getting now? Kindly type it in the chat. What about the value we are getting now? Yes, very good. So we are getting the value as 3, correct? Okay, we are getting the value at 3. Fine. Now this value has to be subtracted from 256. So 256 minus 3, which is equal to 253, which is equal to FBH. Correct? The Baud rate, I mean count value கண்டுபிடிக்கிறதுக்கு என்ன step யூஸ் பண்றோம்? First divided by 12, next divided by 32 or 16 based upon S mod bit, then divided by Baud rate. கிடைக்கிற value 256ல minus பண்ணிடணும். Correct? So the hexadecimal convert பண்ணிடணும். Fine. FD 253 in decimal, which is equal to FD in hexadecimal. Correct or not? Yes. FDH. So the meaning என்னப்பா? நீங்க serial communication UART mode 1ல configure பண்ணிட்டு timer 1 mode 2ல program பண்ணிட்டு count value FD அப்படினு போட்டுட்டீங்கன்னா 9600 baud rate automatically generate ஆயிடும். Fine. This calculation you have to remember. எப்படி பண்ணனும்ன்றது ஞாபகம் வச்சுக்கோங்க. Fine. The TH value எதெல்லாம் டிபெண்ட் பண்ணிருக்கு? S mod bit oda function, operating frequency of the crystal, then baud rate, required baud rate. எல்லாத்தையும் டிபெண்ட் பண்ணி தான் இருக்கு. Fine. Clear? Okay. Now the table given below shows some standard baud rate and the count value to be loaded in TH1 or the corresponding baud rate of 8051 serial UART configured in mode 1, assuming crystal frequency on the 11.0592 தான் இருக்கு. Fine. நல்லா கவனிச்சீங்கன்னா தெரியும். ஸ்மார்ட் பிட் 1 இருந்து baud rate 19200 வேணும்னா 253 போட்டா போதும். இப்போ நம்ம பண்ணது எந்த கேஸ்ல வரும்? செகண்ட் கேஸ் 9600 baud rate, ஸ்மார்ட் பிட் 0, 253 count. Fine. So this is the way you have to calculate the count value. These are some standard baud rates and the count value you have to load. Fine. Now you people understand why we are saying variable baud rate. The baud rate of the serial UART can be varied based upon the timer 1 overflow. Timer 1ல நீங்க போட போற count value கொடுத்து serial UART ஓட baud rate vary ஆயிட்டே இருக்கு. Fine. So steps என்னென்ன ஞாபகம் இருக்கா? FOSC divided by 12. That is first step. What about the second step? That value divided by 32 or 16 based upon the S mod bit. Fine. That value divided by baud rate. So finally you will be having some count value that must be subtracted from 256. ஏன் 256ல மைனஸ் பண்றோம் அப்படின்னு பாத்தீங்கன்னா maximum count value minus desired count value plus 1, that is equal to count value to be loaded. Fine. Correct? That's why we are doing like that. So maximum value 255 plus 1 சேர்த்தீங்கன்னா 256 minus desired count. So இங்க நம்ம சொல்லியிருக்கிறது வந்து desired count. Sorry, count value to be loaded. இந்த count value நீங்க load பண்ணீங்கன்னா automatically அந்த counting generate ஆயிடும். Fine. Now coming to mode 2, 9-bit UART. This is same as 8-bit UART except we will be going to have the 9th bit. The 9th bit can be used for multiprocessor communication or you can use it for parity check. Fine. Odd parity or even parity and check பண்ணிக்கலாம். In mode 2, serial port configured as 9-bit UART. So TXT line RXT of transceiver la connect பண்ணிடணும். RXT connected to TXT of transceiver. So mode 2 is similar to mode 1, but instead of 8-bit, it transmits 9 bits. Fine. The 9th bit can be either parity bit or address enabled bit during multiprocessor communication mode. Fine. So transmission of serial data இங்கேயே அதே தான். 9th bit to be transmitted TB8 ல கண்டிப்பா இருக்கணும். After entire byte has been transmitted, TA flag will get set at the beginning of the stop. Fine. So TA flag automatically clear பண்ணணும் இந்த ISR program of serial interrupt. See, TA flag set ஆயிடுச்சுன்னா அதை clear பண்றது சாஃப்ட்வேர் மூலமா தான் பண்ணணும். Fine. Similarly, reception ல என்ன நடக்கு 9th bit received must be get stored in RB8 ல தான் ஸ்டோர் ஆகும். SM2 bits set ஆயிருந்தா based upon the RB8 value interrupt will get generated. Fine. When the entire byte has been received, RI flag gets set depending on SM2 and RB8. The serial Uart will generate the receive interrupt as follows. SM2 0 இருந்தா RI will be set irrespective of RB8 bit logic. நான் சொன்னதுதான் SM2 reset பண்ணிருந்தீங்கன்னா RB8 பொறுத்து interrupt generate ஆகாது. SM2 1 சொல்லிட்டா RB8 1 இருந்தா மட்டும்தான் interrupt generate ஆகும். 0 இருந்தா interrupt generate ஆகும். Fine. Then regarding the mode 2, baud rate of mode 2. Mode 2 க்கு எப்படி baud rate generate ஆகுது அப்படின்னு பாத்தீங்கன்னா it only depends on the oscillator frequency and S-mod bit. Fine. So formula எப்படி வருது அப்படின்னு பாத்தீங்கன்னா 2 power S-mod by 64 into FOSC. இங்க எப்படி அங்க வருது பாருங்க. If S-mod is 0, என்ன ஆகும் 1 by 64. So இந்த வழியா clock pulse போகும். Fine. If S-mod is 1, then 2 by 64, which is equal to 1 by 32, so divided by 32. See, in the particular diagram of the purpose enna to understand how the serial baud rate is generating in mode 2. Fine. Mode 1 பொறுத்த வரைக்கும் FOSC by 12. Mode 2 பொறுத்த வரைக்கும் FOSC divided by 32 or 64 based upon the S-mod bit. Fine. Mode 1 பொறுத்த வரைக்கும் the baud rate is based upon the timer 1 overflow. That's it. Fine. That's all about the baud rate generation in mode 2. So இதுக்கு ஒரு example பார்த்துடலாமா? Fine. Find the baud rate of serial Uart configured in mode 3. Sorry, mode 2, not mode 3. I think mode 2. Wait a minute. That is for mode 2. Modes வந்து நிறைய இடத்துல மாறி மாறி வந்து. Okay. So we regret for that. Okay. So mode 2 ல இப்ப baud rate எப்படி generate ஆகும்? What is the formula I have told in the previous slide? இத பார்த்தே சொல்லிடலாம். 2 power S-mod divided by 64 into FOSC. Now you people calculate and tell me. The operating frequency is 11.05 into megahertz. S-mod bit is equal to 0. Yes. What about the baud rate? What about the baud rate in this particular mode? Formula inge kuduchachu, correct? This is the formula. Just substitute and tell me. So FOSC divided by 64. That is a baud rate. Kindly calculate and type it in the chat. What about the value for this? Yes, very good. 17,000, sorry, 172,800. That's the value we are getting. What the value we are getting? Sorry. In classroom 2, I am posting for FOSC divided by 64, correct? So which is equal to 17,2800, correct? So that is going to be the baud rate. So that's all about the baud rate generation in mode 2. Mode 3 பொறுத்த வரைக்கும் என்ன சொல்லிருக்கோம்பா? Mode of operation is similar to mode 2. Fine. Baud rate generation is similar to mode 1. That's all. Yes. Is it clear? Mode 3 பொறுத்த வரைக்கும் operation வந்து it is similar to mode 2. Similarly, baud rate generation is similar to mode 1. That's all about the mode 3 operation. தனியா இது படிக்கணும்னு அவசியம் கிடையாது. See, 8 bit Uart க்கும் 9 bit Uart க்கும் ஒரே ஒரு டிஃபரன்ஸ் தான். In the case of 9-bit UART, when you are transmitting, you have to transmit 9-bit, but SBUF is 8-bit only. So the transmitting 9th bit must be in TBA. Similarly, 9th bit receive agadhenga store agum, RB8 la store agum. That's the only difference. Whereas in the case of 8-bit UART mode, whatever the data you are writing in SBUF, it is going to be transmitted in the frame format. Start bit, data bit, then stop bit. So that's all about the serial UART of 8051. Okay, so in the end steps la follow pannom appdin paaklam. What are the steps we have to follow to program the serial UART of 8051? The very first thing, configure the SCON register. SCON register first configure pannu. Then program the timer 1 to generate the desired baud rate. In the case of mode 1 and 3, generally the most common mode of operation what we are going to use is mode 1. Okay, variable baud rate 8-bit UART. 8-bit UART with variable baud rate. That is the most common mode we are going to use. 8-bit UART with variable baud rate. Variable baud rate vary aite irukundra meaning kediyadha. Fine, you can vary the baud rate by fixing the timer 1 mode for it, so that any baud rate you can generate, different baud rates you can generate. Then write a byte in SBUF and wait until the TA flag will get set, or else wait until the RA flag will get set. Fine. See, transmission ஆயிருந்தா SBUF ல எழுதிட்டு wait பண்ணணும் TA flag set ஆகிற வரைக்கும். அதே reception ஆயிருந்தா we have to wait till RA bit gets set. TA bit set ஆகிற வரைக்கும் wait பண்ணா meaning என்ன? Transmission is over. Fine. Reception அப்படின்னா நான் என்ன பண்ணணும்? I have to check for RA flag. That's all about the steps involved in programming the 8051 UART. So again, coming to this particular part, step 2 again, timer 1 program panna porom. So timer 1 stop pannanum, mode of operation configure pannanum, count value for the required baud rate load pannanum. Then we have to run the timer 1. So that steps are involved in step 2 itself. Okay. So that's all about the serial UART programming. Now we will have some questions. How many timers are available in 8051? What is the name of each timer? I think timer or questions in your I think so. Okay. How many timers are available in 8051? What is the name of each timer? Yes. Kindly type it in the chat. Yes, very good. 2 timers are available. What about the name? 2 16-bit, very good. 2 16-bit timers are available. 2 16-bit independent timer bar counter are available. What about the size of each timer? 16-bit. Okay. Next, name the Sfrs associated with serial UART of 8051. So in class la da paathom correct enna register la namakku venum serial UART program pandradhu. Yes, kindly type it in the chat. I'm waiting for your response. See, what are all the Sfrs we are having to program UART of 8051? See, kindly type it in the chat. I'm waiting for your response. இன்னைக்கு தான் கிளாஸ்ல டிஸ்கஸ் பண்ணிருக்கோம் நம்ம. Yes, very good. SCON, SBUF, PCON. Okay, thank you. See, PCON, it is not mentioned here. SBUF is SBUF only. SBUF, SCON, and PCON. Okay. How many modes of operation available in serial UART of 8051? How many different modes of operation we are having? Yes, 4 modes of operation. Which timer of 8051 is used to configure the variable baud rate of 8051 UART? Which timer we have to configure to generate the baud rate for serial UART? Timer 0 or timer 1? That is the question. Yes, timer 1. Okay. So that's all. So now we are going to discuss about the interrupt of 8051. Fine. See, I am moving little faster because we have to cover the portion in time. Okay. If you people have any difficulty or any doubts, you can address. Okay. Is it clear up to this? Is it clear up to this? See, timer or serial UART program la நம்ம எழுதி பழகினா தான் புரியும் என்ன சொல்றோம்ன்றது. Okay. If time permits, okay, once we have completed all the lab experiments, we can go through such things. Okay. As of now, this coming week, Friday, we will be going to have theory session only. Instead of laboratory session, we are going to handle it as theory session only. Once CA portion முடிஞ்சதுக்கு அப்புறம் CA2 குண்டான portion முடிஞ்சதுக்கு அப்புறம் we will have the lab session. Okay. That means after your CA, possibly after your CA2, you can have the lab session. Okay. Now, we all know 8051 have 2 external interrupts, correct? So, what are the 2 external interrupts? What are the 2 external interrupts we are having? 8051 la 2 interrupt irukku, external interrupt. Yes, INT 0 bar, then INT 1 bar. Very good. Okay. What are all the internally generated interrupts? Can you people type it in the chat? இது ரெண்டும் வெளியில இருந்து போகக்கூடிய interrupt signals. Internally generate ஆகக்கூடிய interrupts என்னென்ன பார்த்தோம் இதுவரை? Yes. These 2 interrupts are from the external device. Okay. What are all the internally generated interrupts? Mainly think and answer. இப்போ கூட நம்ம பேசணும் கொஞ்ச நேரத்துக்கு முன்னாடி. Yes, very good Sajis. Very good. Classroom 2 Sajis மட்டும் டைப் பண்ணியிருக்காரு ஆன்சர். Okay, I will ask you one question. When the value of the timer register changes from maximum to minimum, what we can call it as? At least அதுக்கு ஆன்சர் டைப் பண்ணலாமே. என்னோட டைமர் ரெஜிஸ்டர்ல மேக்ஸிமம் வேல்யூ டு மினிமம் வேல்யூ கவுண்ட் சேஞ்ச் ஆனா அது பேர் என்னது? டைமர் ஓவர். வெதர் we got interrupt, timer overflow ஆகிற டைம். Yes, very good, very good. So timer overflow interrupt 0, timer overflow interrupt 1. Correct? Timer 0 overflow interrupt, timer 1 overflow interrupt. ரெண்டு interrupt cover ஆயிடுச்சு. Fine. Then 2 interrupts I have listed. What about the other interrupt? Internally generated interrupt. Both lane interrupt generate ஆக போறதில்ல. கரெக்ட்டா? Port நம்ம program பண்றோம்னா through port we are not going to have any interrupts. Fine. Port pins external interrupt காக ரெண்டு யூஸ் பண்ணிக்கணும். That is the another point. Fine. What we are asking is internally வேற எந்தெந்த மாடியூல்ல இருந்து நமக்கு interrupt generate ஆகும்? டைமர் மாடியூல்ல இருந்து ரெண்டு interrupt வரலாம். ஒரு டைமர் 0 interrupt, இன்னொரு டைமர் 1 interrupt. Correct? Any other interrupt? Out of the 5 interrupt, 2 are external, 3 are internally generated னு சொல்லிட்டேன். அதுல ரெண்டு internally generated நான் சொல்லிட்டேன். What about the remaining one? One more interrupt we are having, internally generated interrupt. Timer overflow interrupt சொல்லிட்டீங்க. Fine, that's good. Timer 1, timer 0, ரெண்டு interrupt. What about the other interrupt? Just now we have discussed. Yes. Okay, partially your answer is correct, Anthony Surya. TI and RI. Okay, TI stands for transmit interrupt, RI stands for receive interrupt. But if any one of this particular event occur, okay, ஏதோ ஒரு interrupt நமக்கு வந்திருந்தாலும் we call it as serial interrupt. We don't have separately transmit interrupt, separately receive interrupt கிடையாது. Yes, very good. Serial communication interrupt. That's all. Serial interrupt simply. So what are the 5 interrupts? I'm typing in chat. Okay, or else I will list here. So CPU of 8051 can handle 5 interrupts from 6 sources with 2 levels of priority. There are 2 external interrupts from external I/O device and 3 internally generated interrupts by timer bar counter and serial bar. Okay. So the external interrupts pins are INT 0 bar and INT 1 bar. We don't have dedicated pin for interrupt. That means what? Port 3 order second bit and third bit. Second pin and third pin, we are going to use it as interrupt. That's it. Okay. So these are the 5 interrupts. External interrupt 0, timer 0 overflow interrupt, external interrupt 1, timer 1 overflow interrupt, then finally serial interrupt. Okay. Kindly take a screenshot of this. So this is the default priority order. This is the default priority order. Which interrupt is going to have highest priority? Which interrupt is having highest priority? Yes, external interrupt 0. Which interrupt is going to have the lowest priority? Which interrupt is going to have the very lowest priority? Yes, very good. Serial interrupt. That's all. Okay. There are 2 levels of priority in 8051 and are low level priority interrupt, high level priority interrupt. Also, we can term it as level 0, level 1. Fine. See here, we are having 5 interrupts. These 5 interrupts can be either programmed to have low level priority group or high level priority group. Fine. நல்ல ஒரு விஷயம் புரிஞ்சுக்கணும்பா. இங்க உள்ள 5 interrupt ரெண்டு கிளாசிஃபிகேஷன்ல ஏதோ ஒண்ணுத்துல நான் உள்ள தள்ளிடலாம். Fine. By default, all interrupts of 8051 is in low level priority in this particular priority order. Fine. You can reprogram it so that you can change the order of priority. Fine. Okay. So இங்க என்னென்ன SFR இருக்கு அப்படின்னு பார்த்தோம்னா, I think you people can say one of the SFR already I have told you. ஒரு SFR நான் already சொல்லிட்டேன். In teaching the timer bar counter itself, I have told you. One SFR, it is common to timer bar counter and the interrupt. Can you identify that? ஒரு SFR, special function register, timer program பண்றதுக்கு யூஸ் ஆகும், interrupt program பண்றதுக்கு யூஸ் ஆகும். No, Shivakumar. Kindly go through all the SFRs and tell me. No, Anthony Surya. See, just see the bits available in the SFR. T-mod la ulla ella bitume timer 1, timer 0 program பண்றதுக்கு தான் யூஸ் ஆகும். கரெக்ட்டா? Yes, very good. T-con. The upper 4 bit of T-con எதுக்காக? Timer program பண்றதுக்காக. The lower 4 bit of T-con for programming the 8051 external interrupts. Fine. IE, IP, T-con. Fine. IE stands for what? Interrupt enable register. Interrupt enable register. Fine. To enable or disable the interrupt, this register can be used. What about IP? Interrupt priority register. For which purpose we are using? To assign the priority level of the interrupt. For that purpose we are having. Fine. Then T-con சொன்னாலும் நான் என்ன சொல்லியிருக்கேன்? Lower 4 bit of T-con can be used to select the sensitivity of the external interrupt and indicates the pending status of external interrupt. Okay, interrupt flag, external interrupt flag bit அப்படின்னு படிச்சோம். கரெக்ட்டா? Yes. So IE stands for what? Interrupt enabled register. IP stands for interrupt priority register. Okay, even though we say T-con as timer control register, the lower 4 bit of T-con is used for programming the interrupt also. Fine. First we will go with IE register. Okay. Okay. In the case of IE register, we are having 2 reserved bits. So the reserved bits அப்படின்னு சொல்றது கண்டிப்பா 0 தான் fill பண்ணணும். For later version of microcontroller. இங்க ஏதாவது மீனிங் கொடுத்திருக்கலாம். Say for example, நம்ம யூஸ் பண்ற 8089S52 it is having timer 2 overflow interrupt. So அதுக்கு இங்க இன்னொரு பிட் வந்திருக்கும், ET2 அப்படின்னு வந்திருக்கும், ET2 அப்படின்னு வந்திருக்கும். Fine. That means regarding Intel 8051 we are having only 5 interrupts. What are the 5 interrupts? Can you type it in the order, priority order wise? Can you say it in the chat? What are the 5 interrupts? The order order solve. Which one is having highest priority? External interrupt 0, correct? Yes. What about the next thing? Timer 0 overflow interrupt, correct? Timer 0 overflow interrupt. Yes. What about the next thing? External interrupt 1, that is having the next higher level priority, correct? Yes. Next, timer 1 overflow, very good. Next, finally, இங்க நல்லா கவனிச்சீங்க தெரியும், E stands for enable. இந்த எல்லா பிட்லயும் எல்லா பிட்டுக்கும் நேம் வந்து E ல ஸ்டார்ட் ஆகுது. That means enable. நல்லா மீனிங்கை புரிஞ்சுக்கணும். E stands for enable. X0 stands for what? External interrupt 0. T0 stands for what? Timer 0. X1 stands for what? External interrupt 1. T1 stands for what? Timer 1. Then S stands for serial interrupt. Fine. So the 5 bits available at IE0, IE1, IE2, IE3 and IE4. This 5 bits corresponding individual enable bit. The 5 bit another individual enable bit. Fine. In the bitoda status, in the bitoda logic will be applied based upon this bit. EA stands for enable all. This pair enable all சொன்னாலும் இது பேரு global disable bit. EA stands for global interrupt disable bit. Okay, global disable bit. What is the meaning for this? இந்த பிட்டை நான் 0 பண்ணிட்டாலே எல்லா இன்டரப்டும் டிசேபிள் ஆகும். இந்த பிட்டை நான் 1 பண்ணா based upon the individual bit the particular interrupt will be enabled or disabled. Please underline my words. Please underline my words. EA enable all அப்படின்னு சொன்னாலும் அதோட பேர் ஆக்சுவல் பேர் என்ன? Global Interrupt Disable Bit. இந்த பிட்டை நீங்க ரீசெட் பண்ணிட்டீங்க, EA-வை 0 பண்ணிட்டீங்க அப்படின்னா மீனிங் என்ன? Irrespective of the 5 bits, நீங்க கொடுத்துருக்க இந்த 5 பிட்டை டிபெண்ட் பண்ணி இருக்காது. All interrupts is going to be disabled. Okay, இதை செட் பண்ணினீங்கன்னா to enable the interrupts if individual enable bits are set. ஓகே, இந்த பிட்டை நான் செட் பண்ணாதான் இந்த பிட்ஸ் எனக்கு எஃபெக்டிவா இருக்கும். இந்த பிட்டை 0 பண்ணிட்டீங்கன்னா மீனிங் என்ன? Disable all interrupts globally. That is a meaning for that. So இதுக்கு ஒரு டயகிராம்லாம் இருக்குது. Later we will discuss. Okay, EX0 enable external interrupt 0. Set பண்ணா enable, reset பண்ணா disable. Similarly, ET0 timer 0 overflow interrupt enable bit. 1 பண்ணா enable, 0 பண்ணா disable. Similarly, EX1, ET1 and EX. Okay, we will have one example. With that we will stop the session. Okay. Find the value to be loaded in IE register to enable all internal interrupts and disable all external interrupts. Can you people say? What about the value I have to fill? What about the condition of EA? First of all, EA must be 1. Very good. What about the reserved bit condition? 0. What about ES? இது எதெல்லாம் enable பண்ண சொல்லிருக்காங்க? Enable all internal interrupts. Internal interrupts என்னென்ன? Serial interrupt, timer 1 interrupt, then timer 0 interrupt. So on the bit மட்டும் 1 பண்ணும். What about the condition of EX1 and EX0? Yes, very good Shivakumar. I think Shivakumar found the answer. Yes. So 9A. So 9A is the answer. Okay. So with this we will stop today's session. I'm going to stop the recording.